Yes, students, in the previous slide we have seen regarding guideways, the other functions, their application, and on what basis they are designed. Here, this slide shows about one of the type of the guideways, that is friction guideways. So these friction guideways are widely used in conventional machine tools due to their good damping properties and low manufacturing cost, like lathe bed movement or sliding movement, etc., depending upon their design, parallelly or in a V shape, whatever, so that both the surface contact will be there between the moving part, so that while operating or in the movement there will be friction. So where here, as it moves to and fro or say forward, backward, so that sliding friction exists. So the coefficient of friction varies according to its velocity, movement of the slide or the bed, you can say. So this coefficient of friction usually for the sliding members or the sliding parts, initially it will be very high, so that for the movement it takes a lot of torque, we can call, or force, and as the speed goes on increasing, the friction also uh, decreases. So therefore this kind of behavior you can call, at the start the high opposition, initial start, and then goes on decreasing, is a kind of phenomenon called as stick slip phenomenon. Stick in the sense, say, adhering to the body or working part. Therefore, that name is given at the moment starting, so that one say for the moment it is high frictions will be there. So afterwards the movement starts as the speed goes on increasing. This phenomenon is called as stick slip phenomenon. Graph, in the graph it can be observed. Starting it will be high, afterwards so that it goes on decreasing. One side the coefficient of friction is considered, and the other side or other axis velocity of slide is considered. So few types in the friction guideways, like say V guideways, parallel guideways, cylindrical type, depending upon the type of the part or the component of the sliding member, or even job also, the work part. On that, based on that, few types are made. The figure what we are seeing, this is a V as well as a parallel type of sliding or guideways. So in these, the parallel alignment of the guideways with spindle axis is not affected by wear, as here upper member fits over the lower member. Exactly, it is the located the surface of the moving part as well as the another part on which it is moving. So this doesn't require even jigs and fixtures also, so that it as it combines flat as well as the V type of guideways. So this diagram little bit important while explaining the particular type of the guideway. Another diagram also here is shown. This includes flat and dovetail type of guideways. So this figure is related with the dovetail, and the first one flat type of guideways. So depending upon the, as I said, the work or sliding member movement, uh, the suitable say type may be utilized or used. And another type, as I said, say for round jobs or say circular type of jobs where rotary movement will be there. In such cases, say this type of cylindrical guideways they are used. The one view which is shown here, the section view of the cylindrical guideway. So as given here in this, the bore in the carriage housing provides support all around the guideway. These are most efficient for relatively shorter traverses and light loads. Even it is dependent on the type of the load also, what type of load and the type of the job or shape of the job. If it is used for the longer traverses, it may sag or bend in the center of the span under the certain conditions or the load which is applied. So these are the few types of the friction guideways as you observed in the diagram, like flat guideway, then dovetail type, uh, then cylindrical type. So according to the diagram, you can see, so it is dependent upon the type of the movement, how the sliding takes place. Accordingly, the construction or the shape is provided for these guideways.